and welcome back to class. In the last video we looked at the mensuration of some solid shapes, namely the cube and the cuboid, and in this video we want to continue our study on mensuration of solid shapes by looking at some other solids. So the first one we'll look at is the cylinder, and I'll start by making a drawing of the cylinder. So your cylinder looks like this. Okay, so we have this as the cylinder. Now let's do some labelings. Remember that the top has a circular outline. So if here's the center of this point, here will be the radius, and from that point down to the center we'll have also the height. So we have the height. Alright, so we have a half of the circular top being the radius, and then the height of the cylinder, which we are going to call h. So we want to derive the formula for the volume of the cylinder and that of the surface area. Now for your cylinder, the volume is given by the base area times the height. The volume is given by the base area times the height. Now what is the base area? The base area, of course, the base of the cylinder is a circle, and we know that the area of a circle is pi r squared. So the area of that circle, the circular base, is pi r squared. Then the height h times height. Therefore this is the formula for the volume of a cylinder. It is given by pi r squared h. The pi r squared is the area of the circular base, then the h for how high the cylinder is, and then that will give you the volume of the cylinder. Now next we'll look at is the surface area of a cylinder. And the surface area of a cylinder is given by the base areas plus the lateral area. I'll call that LA. Okay, I'll explain what that means. Remember that in the last video we established that the surface area would mean the summation of all the area of all the sides that make up the given shape. So for a cylinder, what are the sides that make up a cylinder? Looking at it, we have two circular tops. We have the top of the cylinder, which is also a circle, and then the base of the cylinder, which is another circle. So that means that we're having two circles that we need the area, and again we'll now have the area around the cylinder, just like the circumference of that, and that will be part of the lateral area. Alright, so for the two circular tops, we already know that the area of a circle is given by pi r squared, and because the circle, there are two of them, the base and the top, so that will mean that the area for the two will give us 2 pi r squared. Okay, that's for the base area, that's for the area. Then plus, for us to get the lateral area, that is the sides the circular part of the cylinder. For us to get the area of the circular part of the cylinder, now going around the cylinder, that will give us a circumference, and we know that the formula for circumference of a circle is 2 pi r. Now that circumference would ascend, go up a height known as h. Therefore, for us to get the lateral area of the circular body of the cylinder, what we need to do is to multiply the circumference, which is 2 pi r, times the height of the cylinder, h, and this 2 pi r h will give us the lateral area that we need. Alright, so altogether that will give us the surface area of a cylinder, which is 2 pi r squared. That is for the two circular, top and the base, plus 2 pi r h, which is for the lateral area. Okay, and again, you know, this can also be simplified or factorized because both sides has 2 pi r in common, so we can further simplify the surface area of a cylinder to give us 2 pi r, because 2 pi r is common to both sides. We open up our bracket and we have r plus h. So this is the surface area of a cylinder. Alright, okay, so that is that for the cylinder. The volume is given by pi r squared h, while the surface area is given by 2 pi r squared plus 2 pi r h. Okay, let's look at the next shape. The next solid shape that we'll consider is the cone. So we want to look at the cone. Okay, so I'll start by making a shape. Draw the cone. So for our cone has this shape. Okay, something like this. That's a cone, just like an ice cream. So we have this to be the cone, and remember the top is a circle. So if here is the center of the circle, you can have a radius, and from that center you can have a height. Alright, so here becomes the radius. Let me use a different marker for that. Maybe so we have the radius, and then we have the height of the cylinder. So we have not cylinder, cone rather. So we have the radius of the cone and the height of the cone. Alright, now another part that is what we're mentioning is this part here, this side of the cylinder. If we should consider this triangle that we have formed inside, this becomes what is known as the slant height, which we always represent as the L. So that becomes the slant height. Alright, so for us, the volume of a cone is given by 1/3 of the volume of a cylinder. That's how you remember it. And the volume of a cone is given by 1/3 pi r squared h. Remember that this pi r squared h is the volume of a cylinder. So the volume of a cone rather, is the 1/3 of the volume of a cylinder. So that's 1/3 pi r squared h. That would be easy for you to remember. Now the next one to consider is the surface area. So the surface area of a cylinder, of a cone rather, the surface area of a cone, as we have, is still given by the general formula, which is the base area plus the lateral area. Now, what is the base area? Our cone in this case has just one base area, which is a circular top. Okay, it has a circular top. That's the base area. In this case, just one. So that means that the base area will give us pi r squared. Now, for us to get the lateral area we have is given by the lateral area is given by this value pi r l. I wouldn't want to stress us into how it was derived, but if you must know, it's half of the circumference of the cone times the lateral height. So, but what you just need to know is that the lateral area of the cone is given by the formula pi r l. Okay, the base area, which is pi r squared, representing the circular top of the cone, plus the area of the lateral sides, that's the other side of the cone, which is given by pi r l, and altogether that gives us the formula pi r squared plus pi r l. Or if you want to simplify further, because they have things in common, they have pi r in common, so when we simplify further, we have pi r into bracket r plus l. So this formula serves as the surface area of a cone. As the surface area of a cone. Now we can also get a value for our L. Our L doesn't have an automatic value. We need to derive the value for our L. Now when you consider this triangle, let me draw it out. When we consider the triangle formed inside the cone, here is R, here is H, and then we have the slant height L. And that slant height L, by your Pythagoras theorem, that is the hypotenuse. So you recall that this Pythagoras theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two composite sides. Alright, so that will mean that our L, if we are to evaluate the L, the slant height, the L for the slant height is given by our L squared, which is hypotenuse, is given by H squared, the H squared plus R squared, and that means that our L is equal to the square root of H squared plus R squared, and that will give us the value of our L. So if there is any need for us to compute the value of our L, this is the formula we need to use to derive a value for the L. Then having gotten the value of L, we'll then go back to the formula for the surface area and plug in the value for our pi, for our R, and then for L, and that will give us the surface area that we're looking for. Okay, when we get into problem solving, we'll see how all these are implemented. Alright, okay, so let's look at one more. Let's see. Now we're going to consider a third shape, which is the triangular prism. I want to look at the triangular prism. Okay, the triangular prism. The triangular. Okay. Triangular prism. Okay, that's a triangular prism. So I'm going to go ahead and make a drawing of what it looks like. So you have it to be like this. I have it like this, a triangle, then another triangle. Okay, so we'll join this side, join the top, and then we can use dashed dotted lines to connect the other side of it. Alright, that's a rough sketch, but that's approximately what your triangular prism looks like. Okay, let me try and see if I can make it a bit straight. No, that's okay, something like that. Alright, so we have, let's do some labeling. We have a right angle formed here, a right angle formed here. Considering the triangles, we have right angle formed. So when we consider the triangle, this is the base of the triangle, the triangular side, the base, and here is the height of the triangle. Alright, then let me change some colors now. So this part becomes the slant. It's like a slant height. Alright, so that will be our L. Call that part the L. That is the L. And then we'll have another labeling to make H, and this H is the height, actual height of the pyramid. If the pyramid is oriented to make the triangular base side to be the base, then the pyramid will stand up and have the height H. Alright, so don't get confused. The small h is the height of the triangular side, that's triangular base, while the big H, the capital letter H, is the height, actual height of the prism. Alright, so let's look at the formulas for the volume and the surface area. Let's try to derive that. Now for the volume, the volume is given by the base area times the height. The volume is given by the base area times the height. Now the base area for this triangular prism is a right angle triangle, and the area of a right angle triangle is given by half base times height. So the volume of the prism now, this particular prism equation, will give us half base times height. That's just the area of the triangular base, that is here, then times the height. And of course the height of this prism is the capital letter H. Alright, so this becomes the formula for the volume of a triangular prism. And just like I would say, this is the naming convention that I've employed for this lesson. In some other materials you might see other convention. Maybe you see something like half AB times H. Alright, just know that it is area of the triangular face times the height of the prism. Okay, that will give us the volume of the triangular prism. Now the next we want to look at is the surface area of this triangular prism. We want to consider the surface area, and again, as you know, the surface area is gotten by the addition of all the different faces that the shape has. Alright, so if we want to use the general formula for surface area is given by the base area plus the lateral area. It's given by the base area plus the lateral area. So this is like a formula that will guide us in our derivation of surface area. So for this particular case, what are the base area? Now this prism, triangular prism, has two triangular faces, which you might see as the base in this case, and the area of a triangle is given by half base times height. So for two faces, we're having 2 multiplying our half base times height. That is just for these two triangular faces. Alright, that's the area of those two faces. Now we'll still have 3 more sides to go. Let me change. So we still need to find the area of this part, that is 1. Then the other side, the area of the other side, that's 2. And then of course the area of the rectangular base, the one on the floor, that's the third one. We need to find the area of those 3 sides. When we get them, we'll add them up to the area of the triangular faces, and that will give us the total surface area of this particular solid, the triangular prism. So let's try to find the area of the 3 faces and see what that gives us. Alright, let's take it one after the other. Let's start with this one, the outer one. Now this is like, when we look at that shape, that is like a rectangle, and the area is given by length times breadth. Alright, so the length of this shape, we might call it the h, while the breadth of it is still the slant height L. So we have what we have here is L times h. So LH is the area of this outer side facing us. Alright, now let's consider the other one behind, that is this one. Now if you consider that, now we'll have the length of that side to be capital letter H, while the breadth of it will be the small h that we'll have on this side. Alright, so the area of that side will be the length, which is the capital H, times the breadth, which is a small h. So we're having the small h times the capital letter H. That is that. Then for us to calculate for the other one, that is the one at the line on the floor, that is this one here. If we want to calculate the area of this, now the sides involved, we have the B here serving as the breadth of it, and of course still the H serving as the height of it. So the area of that rectangle on the floor will be the length times breadth. So we're having BH. So altogether, it means that the surface area of a prism, a triangular prism, is given by, now coming back to this place, we have the 2 multiplying half base times height. The 2 cancels the 2, so what we're having is the BH left, so we have BH plus, then for the other, this BH is for the two triangular faces, the area of the two triangular faces. Then we'll sum them up, half base times height plus half base times height. That'll give us base times height, base. And then for the three other faces, the other three faces, we'll have them. So that's our LH plus the small letter h and the capital H plus the BH. So this becomes the formula for the surface area of a triangular prism, a right-angled triangular prism. Okay, this can further be simplified to be BH plus, now when we look at this, we'll see that, okay, this should have been a capital H. Let me see if I can clean that up. Alright, this could have been capital H, that's LH. Alright, now when we look at them, you see that they all have H in common. So what we have here is L plus H plus B in bracket, then you have the capital letter H outside. Now this in bracket can be said to be the perimeter, L plus H plus the base multiplied by the height. Alright, so that's that for your rectangular prism, the triangular prism rather. We have the volume to be the half base times height times the H, and don't forget that the H, small letter H, stands for the height of the triangle, while the capital letter H stands for the actual height of the triangular prism. Now for our L, we'll have to derive L. Now considering this triangle here, remember that it's a right angled triangle that we have. So if we should bring out one of these triangles, what we have is a shape like this, where here is the H, here is the B, and here is the L. So using the formula for Pythagoras theorem, the L in this case is the hypotenuse, so that would mean that L squared is equal to H squared plus B squared. Therefore L is equal to the square root of B squared plus H squared. So this is the formula for our L, this not height. So when we need to calculate the surface area, what we need to do first of all is that we need to utilize this formula here. We need to utilize this formula to calculate our L. Now having gotten the L, we'll then go back to the formula for the base, for the surface area, and plug in the values, simplify, and we'll get what we're looking for. And don't forget that you have to be very careful with your units. When you're solving for volume, you expect to leave your answer in cubic units as your cm cube or meter cube or other given units. Then when you're solving for surface areas, you are also to leave your answer in squared units, your cm squared or meter squared. Okay, so this is it for this video. So we have looked at the mensuration of some solid shapes. We have looked at that of the cylinder as the first one we looked at, and we said that the volume of a cylinder is given by pi r squared h, while the surface area well, we derive it to be r2 pi r into brackets r plus h. Then we looked at the cone, and the cone, we saw that the volume of the cone is given by 1/3 pi r squared h, while the surface area is given by pi r squared plus pi rl, and the slant height L can also be evaluated using the formula that we have here, square root of h squared plus r squared. And the last one we looked at a triangular prism, which we saw that the volume is given by half base times height of the triangle times the height of the prism, while the surface area for it is given by the base times height into bracket. You have your L plus H plus B all multiplied by the H, the actual height of the triangular pyramid. So this is it for this video. In the next video, we'll round off with the remaining solid shapes before we go into the problem solving that involves those shapes. One thing you must know is that you need to commit to memory these formulas. What I've just done is to show you how they are derived. So in a case whereby you don't have anyone, you didn't commit them to memory, you can easily, this will serve as a guide for you to understand how you are to derive the formulas. Okay, that's the essence of what we have been doing so far, for you to understand, not just for you to commit the formulas to memory. That's rote learning. No, I want you to understand why it is what it is. All right. So when you have a good understanding of how the formulas are derived, in a case whereby you can't easily recall them, you just take your time and derive them. They will come back to you. So that's the reason why I'm taking time to go through all these derivations, so that you have an idea of what we are doing. So take your time. You can pause the video, make notes, and go over them. All right, make sure you understand why it is what it is. So in any case of confusion, or you can reach out to me and I'll see how I can maybe lay emphasis on key areas in the next video. Okay, so I'll see you in the next class. Bye.